Hello all, welcome to ClearIAS. Here we are going to discuss the questions which appeared from the subjects of geography as well as science and technology in the 2024 UPSC Civil Service Examination Prelims. So there are in total 29 questions combinedly from both the subjects, and we are going to discuss all those questions one by one, starting from the geography questions. So this is the first question. So there are actually two statements we given. The statement number one and statement number two is there, and then the question is actually based on that. So what is the statement number one? So this question is actually about terrestrial radiation. So let's discuss the two statements. Statement number one, the atmosphere is heated more by the incoming solar radiation than by terrestrial radiation. That was the first statement. Second statement, carbon dioxide and other greenhouse gases in the atmosphere are good absorbers of long wave radiation. So these are the two statements actually being given. And let's discuss what this particular thing that is actually called the terrestrial radiation is about. So when we think about terrestrial radiation, we have to understand how the incoming solar radiation is actually what is the heat budget of the earth. So let's look at how this thing actually works. So let's imagine this is the earth's surface. If this is the actually the sun, and from the sun actually the different rays are actually coming towards earth, and we have to understand that the major part of incoming solar radiation, the incoming solar insolation, it is actually of short wavelength, short length. So that the outgoing is actually on the long wavelength part. So incoming is short, the outgoing is actually long wave. So in that incoming solar radiation, when it actually comes through this, when it is actually coming towards here, we have to understand that there are a lot of gases, a lot of dust particles in the atmosphere, but some of it actually absorbs though a little part of this incoming solar radiation, but only a little part of it is actually being absorbed. So we know that after all this absorption, ultimately what is actually reaching here. So consider if this is actually 100 units is actually coming from the sun, we have to understand that only 51 units is actually reaching earth. So what is actually happening to the other parts, we have to understand that almost 35 parts of the thing, when it is actually coming towards earth, almost 35 units are actually going out. That is actually going out or lost actually before reaching the earth surface. So when the 100 units are coming, 35 units don't even reach the earth surface. It is actually lost to the atmosphere because of the dust and other atmosphere. It is actually lost to the space without reaching the earth surface. That is one part. And the other 14 parts, the rest of the 14 parts is actually lost also. Where how it is actually lost? It is actually absorbed by the atmosphere. So out of the 100 units, leave aside the 14 and the 35 units, only 51 units is actually reaching earth. That is the first point, and all this is actually in the form of short wave. So this is the short wavelength radiation which is reaching the earth. The second part is actually the earth actually gets heated up, right? So all this radiation is actually reaching earth. The earth surface, when the 51 units also is reaching, the earth gets heated up. So what happens when the earth is actually heating up? The earth automatically heats up all the different layers of atmosphere around just above the earth surface, right? So all the layers of atmosphere gets heated up. Why? Because the earth is actually getting heated up. So that is when the outward flow of radiation is actually coming about. That is called the terrestrial radiation. That is, earth is getting heated up, and then the atmosphere layers just above the earth also gets heated up because of the hotness of the earth. That is actually called the terrestrial radiation. So let's look at what the terrestrial radiation units are actually about. So when we look at the terrestrial radiation, we can say that almost 17 units. We know that this is actually 51 units reaching earth, right? So out of that, 17 units are actually getting escaped into the space, back to the space actually. And there are some more actually around 34 units. When it is actually going out, around 34 units are actually absorbed by the atmosphere. So just look at that. When it is actually coming down, almost 35 is lost. 14 is actually absorbed by the dust and other particles in the atmosphere. Then the 51 unit is reaching here. And from the 51 units, that is 17 plus 34 is 51, right? So from the 51 units, when it is going out, 17 is lost. But the 34 units is absorbed by the atmosphere. 14 units is already absorbed by the atmosphere when it was incoming. 34 units is absorbed when it is actually going out. So when as you can see from the units division here, we know that the outward flow of the radiation, it is then the actual temperature, actual heat energy is absorbed by the atmosphere. When it is coming, only less units are absorbed. When it is going out, maximum unit of temperature, heat energy is actually absorbed by the atmosphere. So this is the case in which background in which the question is actually asked. So let's coming back to the question. What is the second statement? Carbon dioxide and other greenhouse gases in the atmosphere are good absorbers of long wave radiation. So when it is going back, it is definitely long wave, and this long wave radiation is better absorbed by the carbon dioxide and other greenhouse gases. So that is why we actually talk about the pollution, right? All the carbon dioxide and other greenhouse gases we are emitting are, getting stagnant in the atmosphere. That is where the temperature of Earth is actually increasing. The global warming is actually happening. So this carbon dioxide and all other pollutants are definitely a causative factor. And this particular thing is actually because of the long wave radiation, that is the terrestrial radiation emitted by the Earth. So the second statement is actually correct. And what about the first statement? The atmosphere is heated more by the incoming solar radiation than by the terrestrial radiation. That is wrong, right? So as we saw in the earlier figure, the incoming radiation, the atmosphere absorbed only 14 units, but when it was going out, almost 35 units was actually absorbed by the atmosphere. So when it was actually going outside, it was then maximum units of energy was actually absorbed. So the statement number 1 is actually wrong. So the statement number 1 is incorrect and the statement number 2 is correct, which means that D is the answer of that particular question. Let's move ahead. So we are into the second question from the geography section. So consider the following statements. Again, two statements are actually given. Statement number 1 and statement number 2 was actually given. What is the statement number 1? Thickness of the troposphere at the equator is much greater as compared to the poles. So they're saying that there is as we know the different layers of atmosphere, right? So just above the Earth's surface there is troposphere, then there is stratosphere, just like that. We have already studied in our science and technology classes as well as in your study materials also. These are the very basic things. So they are saying that the initial first layer of atmosphere, that is the troposphere, it is actually much greater height in the it is actually of much greater height just above the equator compared with the poles. That is the first statement. Second statement, at the equator, heat is actually transported to great heights by strong convectional currents. So these are the two statements which is actually being given. So let's understand how this actually works. So when we look at the equator, they are actually saying that if we consider this as Earth, we know that Earth gets heated up, right? When there is actually, when the incoming solar radiation is there, Earth definitely gets heated up. And what happens at the equator and the poles comparingly? So we know that in the equatorial side, there is more incoming solar radiation, more direct light is there, it gets more heated up. But in the polar side, it is actually more cooler, right? So this region is actually more warm, you can say that, and this region is more cool also. So what happens in a region where there is more warm? When it is actually more warm, which means that the air, the atmosphere in above that particular area will be more heated up, right? All those heat energy will be traveling upwards to the atmosphere. So if this is more warm, which means that the heat energy will be moving much larger height. And here also in the equatorial region, it will be going to very larger heights will be going. But just look at the polar regions. It is not that much warm. So whenever there is a warm air, it always rises up. But in the polar region, the air is not that much warm compared to the equatorial region. So which means that the air will not be rising to greater heights. The air will be rising to only smaller heights only. And all these things are actually caused by convectional currents. So because of the convectional rise of those currents, the air masses actually always goes up. The warm air mass always goes up. So just look at that. If the equatorial region has more height, when we draw the troposphere map, we can actually see that the equatorial troposphere is actually very high, but the polar troposphere is actually very less height. So we can identify that in the troposphere, in the equatorial region, it is almost 10 to 18 kilometers of height is there in the equatorial, not 10 actually, 16 to 18 kilometers of height is actually observed. For what? The troposphere is actually observed just above the equatorial region. But when it is actually in the polar region, it is actually comparatively very less. We can say that it is only 8 to 10 kilometer regions of temperature of kilometers only. That is the height of the troposphere in the polar regions. So why this is actually happening? Because of the convectional current. That is the warm air mass rising. That is the main reason of the difference between the troposphere's borders. So let's go back to the question here. So what is the question? Thickness of the troposphere at the equator is much greater. Yes, definitely. The thickness or the height of the troposphere at the equator is definitely much greater or higher compared to the poles. That is a correct statement. The second statement is that at the equator, the heat is transported to greater heights. That is right? The transported to great heights by the strong convectional currents. So convectional currents are the reason. So both statements are correct. And the second statement is actually the exact reason or explanation for the first statement. So what is the key here? A is the key. That is both the statement 1 and 2 are correct. And the statement 2 explains statement 1. So this is the answer. A is the answer. So let's go to the next question. All right, this is the third question here. So what is the question? Consider the following. And there are 4 things actually being given. What are the 4 things? Pyroclastic debris, ash and dust, nitrogen compounds, sulfur compounds. So how many of the above are products of volcanic eruption? So that is the question here. So as you know, in the volcano, when it is actually getting erupted, some of the volcanoes can be acidic, some can be basic. So you must have actually studied about the acidic volcanoes, basic volcanoes. There are different other types of volcanoes also be based on their shape and size, etc. If there is violent, if it is actually more peaceful, lot of different classifications are actually there. But more or less in every type of volcanic eruption, what is actually coming out? We can say that we know what it is actually called the magma. So magma is actually the molten rock materials which are actually formed within the earth. When it is actually coming outside of the earth's surface through these kind of eruptions, it is actually called lava, right? So when these eruptions are actually happening, lot of other particles are actually coming. For example, some of the rock materials, some of the rock fragments, all these things are actually coming out along with this particular magma. And we can call this as actually the pyroclast. So that pyroclast is actually extremely important. So what are actually, as you can see from the image here, it is actually a flow of the pyroclast. It is actually coming out from the volcano and it is actually going downwards based on the gravity flow that is actually going. That is actually called the pyroclastic flow. So what is this pyroclast actually? So we can say that pyro is actually fire and this clast, which means that it is actually broken. So this is actually broken particles, broken rock materials, which is actually flowing along with the lava and other particles. So we know that in this particular volcano, when we go to our previous question, we should know that this particular volcanic eruption, any volcanic eruption may contain this pyroclastic debris or pyroclastic flow. That is one point. And definitely lot of different, whenever there is an explosive volcanoes are actually happening, it is said that for the next, few days or few months or maybe depending on the violent nature of the volcano, the earth may get cooled down. Why? Lot of different particles are actually emitted outside of the volcano, right? Lot of different dust, ash, lot of different particles are emitted. And when these ash and dust particles are emitted outside of the volcano and when it is actually getting stagnant in the atmosphere, what happens is that the particular dust and ash, it blocks the sunlight from coming from the sun. It will not reach the earth, those sun rays. So ultimately the earth will go, it will cool down for momentarily for some time after a major volcanic eruption. So that is the story. But there are some side effects also, even though it is actually cooler for the initial days. What happens if the sunlight is not reaching earth? There is no photosynthesis, right? The rate of photosynthesis will fall down if there is no sunlight. So there are drawbacks of that also. So that those kind of stories, if you know those kind of concepts, you should already be knowing that ash and dust is definitely a part of these volcanic eruptions. Then nitrogen compounds, sulfur compounds, all these things are actually basic components whenever there is a volcanic eruption. All these magma particles, all those lava, when it is actually coming out, all that contains different components such as nitrogen, sulfur, etc. So though all those things are actually part of the products of volcanic eruption. So our answer is actually D, that is all 4. Let's go to a next question. Which of the following countries are well known as the 2 largest cocoa producers in the world? So this is actually an equatorial crop, which means that the regions in and around the equator, that is actually producing more amount of cocoa. So what is this particular crop? It is the crop that actually finally reaches us in the form of different products are there. However, the most famous one is definitely chocolate. chocolate is created out of this cocoa plant, and we can look at the map of this particular continent that is called Africa. A lot of questions were actually being asked from the African continent also. For example, there was another question that is on the Sahel region. That is a repeated question. So different questions are actually, and one question that is on peatlands. So we'll be discussing that question also. So different questions are actually asking in and around the continent of Africa. So make sure that, and it is actually being repeated also. So make sure that you are actually thorough with the concept and different factors or the different news actually which are coming out of the African continent. So let's coming to the particular question, that is which of the countries are actually having major cocoa production. So when we draw a line, that is the equatorial line, you can see that it is somewhere here, and the Cote d'Ivoire, that is the Ivory Coast, the country, and just near there is Ghana also. So the two countries of Cote d'Ivoire and Ghana, these are the major producers of cocoa plant in the world. So that is actually a very basic thing. That is the directly asked question. So UPSC is telling us that you have to be familiar with the different major crops of the world, major cash crops of the world also, and where these crops are actually being cultivated also. So these kind of things has to be studied when we are actually going ahead. For example, there was a question asked on the largest rice producer also. So rice, wheat, all those questions are repeatedly asked. So make sure that we be thorough with the different crops and the different regions where the crops are cultivated. So let's go to the next question. The question is, with reference to the Himalayan rivers joining Ganga downstream of Prayagraj. So we have to understand about the different tributaries of Ganga, one point, and downstream of Prayagraj. So we don't have to worry about the each and every tributaries of Ganga, only on the downstream of Prayagraj only. From west to east. So from west to east, that is from the, if you are drawing Ganga, we should know that Ganga is actually flowing something like this. And this is the western part, and this is the eastern part. So we are actually counting or going to identify the tributaries from the initial place to the ending place. From west to east, which of the following sequence is actually correct? That is the question here. And when we're drawing, this is one another aspect. So in the Indian geography part, we have to understand that there are several rivers, major rivers are there. For example, Ganga, there is a Brahmaputra is there, then there is Indus is there. Then there is coming to the peninsular rivers, for example, Mahanadi. Then there is Godavari. Then there is Krishna. And then there is Kaveri also. Then the two other rivers which are going to the western direction, that is Narmada and Tabi. Both are actually flowing through Block Mountain, rift valleys also. So these are the major rivers in India. So we have to be very thorough regarding the different tributaries of these rivers and the direction of the tributaries also, whether it is actually joining from the left bank or from the right bank. So these things have to be understood. So for that, it is the very basic thing we can do is drawing a map of very simple map of a river. For example, this is the skeletal form of a river Ganga. So how it is actually originating from those Gangotri glacier. It is flowing through from the Uttarakhand state, it is flowing through Uttar Pradesh, Bihar, West Bengal, and eventually ending at the, emptying at the Sundarban region, that is the Bay of Bengal region. So this is the basic skeletal framework of Ganga, and we can actually draw the different tributaries of Ganga also. For example, this is actually the tributary that is actually called Yamuna. So Yamuna is actually joining Ganga, and it is a right bank tributary. So just like that, the question is actually asking, giving us four statements, four rivers, arrange the following. So the correct answer here is actually B. That is Gomati, Ghagra, Gandak, and Kosi. That is the way in which these rivers are actually joining here. For example, it is the Ganga is actually flowing like this. There is actually Ram Ganga is actually here, and then comes actually Gomati River. So this is actually Gomati River, and after Gomati River is there, then there comes the Ghagra River is there. So there is Ghagra, right? Ghagra River is there. It is actually joining Ganga like this. So this is the direction of flow, Ghagra River. So once the Ghagra River is actually joining, then comes the Sun River is actually coming from this direction. Sun is not actually asked. And then the Gandaki River is there. And then last but not the least, the Kosi River is also coming. So we can actually create miniature maps like this of any major river. So I just mentioned about the different major rivers in India. So make sure that you just go through with the different river systems, draw the skeletal map of the system, and then accordingly join with the different tributaries or distributaries of the particular river. For example, Ganga has different distributaries also, like the example of Hooghly River. It is a distributary of Ganga, not the tributary. So just like that, draw the basic map, and you will definitely, it's a very easy question. if you do that particular exercise. So the answer is actually B. Going to the next question. So here comes the three statement question. So this was earlier there used to be two statements, right? Statement number one, statement number two, and statement number two is the correct explanation of the statement number one. So here we have got three statement questions. So we are going to into that particular question. Statement number one: rainfall is one of the reasons for weathering of rocks. And the second thing, so which is actually a right statement, right? So rainfall is definitely one of the reasons for weathering of rocks. And when we consider this word weathering, don't misunderstand with the concept of erosion. So weathering and erosion both are actually entirely different. Weathering means actually disintegration of that rock, plucking down of that rock. The rock actually disintegrates in a different small pieces. That is actually called weathering. But what is actually erosion? When there is actually plucking down and then the movement of that particular debris or the transportation is also part of it, then it is actually called the erosion. So both the erosion and weathering is actually different. And rainfall definitely is one of the reasons of the weathering of the rocks. It's a very fundamental thing we study in geography. The second and third statement, second statement, the rainwater contains carbon dioxide in solution. That is actually correct. So because when definitely our atmosphere is actually containing a lot of oxygen as well as carbon dioxide, and when the rainwater is actually coming downwards, which means that all those rainwater, all those liquid is actually definitely containing a lot of oxygen as well as carbon dioxide particles. And when these things, when the rainfall containing all these particles are actually attacking this particular rock, which means a lot of different mechanical action is definitely happening. Along with that, a lot of small chemical reactions are definitely happening. So which means that the rock will be disintegrated faster. So that both the statement number 2 and statement number 3 are actually correct. And both these things are actually giving proper explanation to the statement number 1 also. That is, the rainfall is in favor of the disintegration of the rocks through the method of weathering. And we have to also keep in mind that when the temperature is high and the rainfall is high, when the temperature as well as the rainfall, when both of these things are actually high, which means that the weathering will also be in a very high speed. That will be happening. And when the rain has more oxygen, when the rain has more nitrogen, when the rain has more carbon dioxide, etc. also, and the particular status of weathering, the rate of weathering will also be very high. So this is the thing. Both the statements are correct, and both these 2 and 3 statements clearly explain the statement number 1. So the answer is actually A. Coming to the next question. So it is a purely map-based question. Consider the following countries. So they gave 4 countries: Finland, Germany, Norway, Russia. So how many of the above countries have a border with the North Sea? So we are going into the question. We should know that the North Sea actually has 7 countries which are actually bordering. So which are the 7 countries? We can see from the figure itself. So this is the North Sea here. So which are the 7 countries? There is UK, that is 1. France is 1. And then the Belgium is 1. Germany, Netherlands, Denmark, Sweden, and Norway. So these are the 7 countries which are actually bordering the particular thing called North Sea. So don't confuse it with English Channel and all. English Channel is actually located between France and the UK, Britain actually. So this is actually the North Sea, and we saw the 7 countries which are actually bordering the North Sea. 7 countries bordering North Sea. Coming back to the question, which are the countries we just saw? For example, Finland was there, definitely. The Germany is there, Norway is there, but we don't see any Russia in this particular thing. So which means that which are the 2 countries which are actually bordering this particular North Sea? That is actually B. Only 2 is there. There is no Russia. Only Norway. Only Germany is actually there. So these are the 2 countries joining this thing. There is no Finland also. Only Norway and only Sweden is there. The Finland is actually not part of it. Norway, Sweden, Denmark. These are the Scandinavian countries bordering the North Sea, which means that there is no Finland, there is no Russia, only Norway, only Germany is there. So only 2 is the answer. B is the correct answer here. Let's go to the next question. Yes. So this is another type of newer attempt by the pattern change by the UPSC. They are giving us pair-based questions. It is actually match the following, but pair-based questions, but on 3 different columns. So what are the 3 different columns? One is actually waterfall, and where is the particular waterfall located, the region of the waterfall, and which river is actually causing that particular waterfall. So these are the 3 pairs we have to arrange. You have to find which is actually the correct pair. So how many of the above rows is given of the given information is correctly matched? That is the question. So coming to the question, we can see that The Dhuandar Falls is actually a part of Narmada only. So this is actually correct. Dhuandar is actually part of Narmada only, but this is not actually in the Malwa Plateau. That is actually in the state of Madhya Pradesh, that is in Jabalpur region. So that is not in the Malwa Plateau, which means that this pair is actually wrong. So both the Dhuandar Narmada can be matched together, but it cannot be matched with the Malwa Plateau. Next thing, Kundru, that is the waterfall, and then the region is Chota Nagpur, and the river given is actually Subarna Rekha. The river Subarna Rekha is actually being given. But we can see that these three things are actually correct. So this particular Kundru river is actually flowing through, for example, Ranchi. It is flowing just near Ranchi and all. And this Ranchi is actually part of Chota Nagpur plateau, and it is actually the part of the river Subarna Rekha. So this particular pair is actually correct. And the third particular pair is actually Gersapa, that is the waterfall. And that Gersapa waterfall has another name that is actually called the Jog waterfalls. So it is actually Jog waterfalls, and it is definitely in the Western Ghats region. That is actually correct, but it is not in the Netravati river, but it is actually on the Sharavati river. It is actually on the Sharavati river, the Jog waterfalls or the Gersapa waterfalls is there. So this pair also becomes wrong. So what is the only pair which is right? Kundru, that is actually going through Chota Nagpur region, which is on the Subarna Rekha river. So only one pair is actually correct. So A, only one is the correct answer here. Let's go to the next question. So another pair-based question, that too in the three different columns. So what is the three different data which is being given? A region is actually being given, and in that particular region, if there is any mountain range, the name of that mountain range is given, and what type of mountain is that? That type of column is also given. So we have to match this particular thing. So going to the particular thing, we know that there is a fold mountain, block mountain, two different names are actually given. We know what is actually the fold mountain, what is actually the block mountain. The fold mountains are actually created by compressional stress, and the block mountains are created by tensional stress. When it is actually going, apart like that, a rift valley is actually created in between, and block mountains are created. And when it is compressional stress is there, fold mountains are actually created because of the compressional stress. And we definitely study the different types of fold mountains, the different examples of fold mountains also. So when we look at the fold mountains, we should know that there are young fold mountains are there, and then the old fold mountains are also there. So when we look at the young fold mountains, there are four major young fold mountains in the world. Which are the four major young fold mountains in the world? For example, one is actually Himalayas. The second, that is actually in the Indian subcontinent only. The second is actually in the Alps. That is actually in the Europe. The third is actually Rockies in the North American continent. And the next is actually Andes. Andes is actually in the South American continent. And this is the way in which fold mountains are actually being classified. And then there is one another fold mountain, that is actually old fold mountain. One of the best examples is actually Appalachians. Appalachians is actually in the United States of America, and that is actually, it was a very high grade fold mountain in the ancient past, but now it is actually degraded. So it was an ancient fold mountain, so we can call it as like a old fold mountain. So these are the major fold mountains in the major examples of fold mountains in the world. Now let's look at the different pairs. We see the third pair. So North America, there is Appalachians, there is fold mountain. That is actually correct. This is an old fold mountain. That is actually in the United States of America, that is in the North America, that is Appalachians. So this pair is actually correct. So the next thing, South America, then there is Andes, there is fold mountain, that is correct, right? So we know that there is a young fold mountain that is called Andes, that is in the South American region itself. So this particular pair is also correct. The next one, the second statement, second pair, Europe, there is Alps. Yes, Alps is actually definitely located in Europe. It is called the block mountain. There it is actually wrong. So it is not a block mountain. It is actually a fold mountain. It is a young fold mountain that is called Alps. And then next thing, Vosges mountain ranges that are actually fold mountain ranges that are in Central Asia. Then it is actually wrong. Actually, that particular thing actually is wrong, because Vosges is actually located on Europe, that is in the near the country of Germany, and it is actually a block mountain range. So there is actually a Rhine Valley, that is the Rift Valley, which is actually created because of the block mountain. And so there is a Rhine Valley, that is the Rift Valley, and then there is a Vosges mountain, that is actually the block mountain. And these things, these particular block mountain and the Rift Valley is actually in the European continent, not in the Central Asian continent. So this thing also becomes wrong. So only two pairs are actually right here, which means that B is the correct answer here. I hope it is clear. Let's go to the next question. So as you can see, there are lots of different map-based questions are actually here. And whenever you're studying any concept like lakes or fold mountain, block mountain, glaciers, whatever it is, make sure that you tag it. Like for example, you just study examples relate with it, because whenever you're studying examples, you can get direct map-based questions like this. Let's go to the next question here. So with reference to water vapor, which of the following statements is or are correct? Two statements are actually being given. The first statement, it is actually a gas, the amount of which decreases with altitude. First statement. The second statement, the percentage of a water vapor is actually maximum at the poles. Two statements are there. So let's look at the scientific facts behind it. So when is actually a water vapor formed? So the water vapor is actually the gaseous form of water, right? So there is ice, then it becomes water, then it becomes, so there is ice, then it becomes water, the liquid form, then it becomes water vapor, right? So when it is actually warmer, there is water vapor, which means that wherever there is warmer water, the content of water vapor will be more, right? So let's look at the second statement. The percentage of water vapor is maximum at the poles. So in the polar region and in the equatorial region, when we are comparing, the equatorial region has got warmer waters, right? Because there is more intense heat, the sunlight is actually direct, it is more heat, there is more warm, which means that the amount of water vapor in and around the atmosphere, the equatorial region will be more, which means we can scientifically state that in the equatorial region, almost 4% of the atmosphere by the volume is actually water vapor. But when it is actually in the polar region, it is actually only 1%. So the amount of water vapor in the polar region is less. But here the statement is the percentage is maximum at the poles, which means that the second statement is wrong. First statement, it is a gas, of course, the amount of which decreases with altitude. That is actually right? So for example, when if this is actually sea, if the sea is actually getting warmed up, the water vapor will be forming here and it will definitely be rising. But just near to the sea top, just touching the sea surface, that will be the region which has more amount of water vapor. As we go higher, the amount of water vapor that is actually reaching greater heights will be less. So just near to the sea surface or the earth surface, there will be more water vapor. As we are actually going up, as the height increases, the amount of water vapor will also be decreasing. So it is inversely proportional. So the first statement is actually right. That is, as the altitude increases, the amount of water vapor decreases. So that is the second statement. So that is the first statement, that is actually correct. So the answer is actually here, A, that is one only. That is the first statement only, that is the correct answer. And you should also keep in mind that the water vapor, it also helps to absorb a little bit of solar radiation, thereby keeping the earth actually very warm. So the earth is actually very cool planet. So we are actually experiencing a very warm climate, warm temperature. Why? Because a lot of such particles such as water vapor and some of the greenhouse gases also, some of those particles help trap the solar radiation within the atmosphere. That is why the earth is actually warmed up. So that is why we are actually living. The life actually formed, the life is continuing because of that trapping of warmth from the sun. If there is no atmosphere, if there is no water vapor, no such greenhouse gases, then all the atmosphere will be gone. Then the earth will be extremely cool down planet. So we have to understand that all these things are actually required. Even the greenhouse gases, all those things are required, but in a very limited amount of quantity only, in a very prescribed limited quantity only. It should not be very high, it should not be very less, it should be in a very range of limits only. Only then life can actually survive. Going ahead to the next topic, next question. So there are three statements are actually given, and they are asking us which type of climate actually explains these three statements. So first statement, annual and daily range of temperature is actually low. So that means that almost same range of temperatures, not that much high fluctuation is there. If the summer is there, when the winter comes, there is not a sharp drop of temperature. Both the summer and winter are having almost same with the minor fluctuations only. First statement. Second statement, precipitation occurs throughout the year. So which means that continuous rainfall is there. Only some small intermittent breaks are there. But however, when we look at overall rate, annually there is continuous rainfall precipitation throughout there. Precipitation can be rainfall as well as snowfall also. So there is continuous precipitation. Third thing, the precipitation varies between 50 centimeter to 250 centimeter. So we have to understand that when we look at the different types of biomes when we study, there are different types of biomes, right? For example, savanna zone is one, the desert biome is one, the equatorial type of climate is one, so different Mediterranean type of climate is one. For example, we have to identify some catchwords. For example, the tropical climate or the desert climate or the savanna climate, we can say that it experiences maximum amount of rainfall during the summer season. Why? Because it is actually in and around the equatorial tropical region where there is actually it is actually in close contact with the warm waters. So whenever there is warm water, there will be more water vapor there. So this water vapor come above the continents and all. It becomes rainfall in the form of convectional rain or in the form of orographic rain. So it is in the summer season the equatorial and the tropical region mainly experiences rainfall. Here they are saying that the precipitation is occurring throughout there. Let's look at the Mediterranean zone. So Mediterranean biome is actually experiencing the rainfall mainly in the winter season, not in the summer, but only in the winter season the rainfall is concentrated. So that it is actually not talking about the Mediterranean climate also. So this is how you actually try to eliminate or try to figure out what type of climate this particular thing is actually about. So we have to understand that this is actually the British type of climate, or you can say the marine west coast climate. So the characteristics which are actually given in the three sentences are actually characters of the marine west coast climate, or in other words, the British type of climate. And why it is called the British type of climate is that because that the Britain land is actually one of the important regions where this particular climate is observed. So we can identify the regions. It is just above the Mediterranean climate. So it is actually the main regions are definitely the land of Britain. The British climate is actually observing this particular thing. Then there is the Northwest American region here, just along the coast of Canada and the North America. That particular region is actually intensively affected. And then there is Southeastern Australia, and then there is New Zealand. These particular regions are actually experiencing this climate. And then Southern Chile also. The Southern Chile part also are experiencing the major influence of this particular climate. So these are the regions mainly experiencing this climate. And we already learned about the different factors. That is, there is low annual temperature is there because, and there is one important reason also because summer season, just imagine if there is actually 25-degree, 30-degree temperature is there. Just imagine there is actually ocean currents, right? So we mentioned about ocean currents in the one of the previous slides also. So when the ocean currents are there, the North Atlantic drift and Gulf Stream, all these ocean currents are going and concentrating in this particular area, which means that when the winter is happening, when the January month is actually happening, it was actually supposed to be very cool, right? It was supposed to be 0-degree climate, something like that, because it is very near to the polar region. But because of these warm ocean currents, what happens is that the winters are mild. It is not that much cooler. It is actually comparatively mild, which means that the summer as well as the winter, they're actually having not that much temperature difference. The range is actually within the limits only. So that is one of the factors which was actually being said in the statements. And the precipitation, definitely, it is actually in the westerlies region. So we know when we draw the planetary winds map. So when we draw the map like this, then there is here we have got the trade winds, and the next thing is actually westerlies. So this particular region is actually on the westerlies part, right? So this is actually on the westerlies area, which means that it will be onshore. So westerlies will be taking all the moisture and it will be taking rainfall into those particular regions of this region. So which means that it is actually continuously getting rainfall or precipitation also. So the three statements are actually pointing to one particular type of climate that is called the British type of climate, or in other words, the word is marine west coast climate. So that is the answer. D is the answer here. So going into the next question here, with reference to Coriolis force, consider the following statements here. So what is actually Coriolis force? So Coriolis force is actually generated because of the rotation of the Earth. So this particular force, it is actually causing all those moving objects in our atmosphere. If it is not actually grounded in the Earth, if it is actually floating in the atmosphere, this particular thing, Coriolis force, actually deflects those particular objects. And how this particular is actually objects are deflected, it is actually causing deflection towards right in the northern hemisphere and left in the southern hemisphere. So this is the direction in which Coriolis force deflects a particular object if it is actually in the north as well as southern hemisphere. So why this particular Coriolis force is happening? Because of the rotation of the earth. So let's look at the different statements. Coriolis force, it increases with increase in the wind velocity. That is statement number 1. And the statement number 2 is it is maximum at the poles and it is absent at the equator. So we can say that both these statements are actually correct. Both these statements are actually correct. So let's understand how this thing actually works. So as you know that we already mentioned about that it is actually for deflecting the particular thing towards the right. So this is actually going right and this is actually going left in the northern hemisphere as well as the southern hemisphere. So what happens is that this Coriolis force is actually very much weaker at the equator and it is actually increasing manner to when we go to the higher latitudes or towards the poles, we can say. So this Coriolis force is actually proportional to the rate of decrease of Earth's rotational speed. So if you are located at the center, or you can say the core of the earth, if you are actually entirely situated on the, if you consider the earth as a sphere, you are located on the core of the earth. And if you are actually looking up towards the surface of the earth, you can see that the equatorial region is actually moving at a very high rate speed, but the polar regions are actually not moving at very high rate of speed because it is only spinning like that. But the equator is actually moving like this, so which means that the speed is actually very high. So that particular perception is actually being created. That is one important concept which you have to keep in mind. So which means that the particular thing Coriolis force is actually proportional with the rate of decrease of Earth's rotational speed. And it is actually proportional to the velocity of the moving object also, the wind moving object also. So when the wind actually increases, the Coriolis force acting on this particular object will also be increasing, which means that the deflection will be more. You can directly say that the Coriolis force is proportional to the velocity of the wind acting on that particular body also. So the next thing is actually about if the earth actually, what if the earth actually stops rotating? You can just imagine a situation like that. If the earth actually stops rotating, we already mentioned that Coriolis force is actually originating because of the rotation of the earth, right? So if the earth actually stops rotating also, the Coriolis forces will cease to exist. There will not be any Coriolis force also. So the causative factor of Coriolis force is the Earth's rotation. That also has to be kept in mind. And we can easily identify this concept. For example, if we are actually traveling from one place to another, for example, if you are actually traveling from Morocco or in India also, if you are traveling from Kanyakumari to Delhi, straight line, right? If you are taking the map of India, it is actually straight line. If you're starting from Kanyakumari and you're going to Delhi, New Delhi, so just imagine, if you go by road and all, you will feel that it is actually on a straight line. But you're actually flying, right? You're actually going like this. You're going like this and you're landing somewhere else. But once you are up, the earth is also moving towards this side, right? So you will be landing somewhere here. You will not be landing on the New Delhi part, but you will be landing somewhere elsewhere because once you're up in the earth below you is actually rotating. So if you're going in the straight line, you will land somewhere else. You will never land in New Delhi. But if you're going in through the land or through the shipways, waterways, you will never come to know about this particular change of air because you are always moving along with the air. But once you are up in the air, which means that the Coriolis force and all these things will be acting upon you, you will definitely be landing somewhere else along with because of the rotational movement of earth below the aerial movement also. So that also has to be kept in mind when the particular concept of Coriolis force is there. So let's go to the next question. That is actually regarding the summer solstice. So this particular date on June 21, that is generally considered summer solstice. And what is this particular date of June 21, summer solstice? So when we consider equator like here, Tropic of Capricorn, Tropic of Cancer. So this is actually Tropic of Cancer. And the sun, or we can say the apparent movement of the sun appears to be situated above the Tropic of Cancer on this particular date. So that is called the June 21 summer solstice when the apparent movement of sun is actually located above the Tropic of Cancer. So let's look at the different questions or possible options being given. On June 21, that is the summer solstice day when the sun is above Tropic of Cancer, which of the following latitude experiences sunlight of more than 12 hours? That is the question. And 4 different options are actually being given. The equator, Tropic of Cancer, Tropic of Capricorn, Arctic Circle. So let's imagine like that. So when the sun is actually located just above the Tropic of Cancer, it automatically means that the region around Tropic of Cancer will be having more sunlight, right? So if the sun is actually here, at that particular time, we should know that the Arctic Circle, right? The above the Arctic Circle is there. All those Arctic Circle will be experiencing 24 hours of sunlight. The sun never appears to be setting. The sun is always in and above the horizon at that particular time. So this particular region will always be having more than 24 hours. We can say almost 24 hours of sunlight is continuously in the Arctic Circle. So one point is actually clear, right? The Arctic Circle is actually clear. It is actually 24 hours of duration is there. We are only asking about more than 12 hours. So these are experiencing more than around 24 hours. Full day, the sun is actually there. So Arctic Circle I can count. Look at the Tropic of Cancer area. So it is actually located above Tropic of Cancer only, right? So from Tropic of Cancer towards the equatorial region, we can say that it will be experiencing more than 12 hours of sunlight. So even in the equator region, it will be experiencing more than 12 hours. So for example, around 13 hours of daylight will be there. The sun will be around above the horizon for more than 12 hours, around 13 hours out of the 24 hours in a day, which means that this entire region will be having experiencing more than 12 hours of sunlight. What is the odd one out here? The Tropic of Capricorn, which is actually situated in the southern hemisphere. They will not be experiencing more amount of daylight in those particular time. They will have a very less amount of sun. The sun will be coming out of the horizon and will be going out in less than 12 hours. So only we can strike off Tropic of Capricorn. All the three will experience more than 12 hours of sunlight. So 1, 2, and for this particular equator also we can actually count, right? So equator will be experiencing only 12 hours. So these two things, the Tropic of Cancer as well as the Arctic Circle, they will be experiencing more. The Arctic Circle will be experiencing 24 hours of sunlight. Tropic of Cancer will be experiencing around 13.5 hours of sunlight. So these two things can be counted. The equator is actually experiencing on 12 hours, exact 12 hours of sunlight. So it is actually on the very same day, it is above the Tropic of Cancer, right? So exactly 12 hours of daylight, exactly 12 hours of night time. So 12, they are asking more than 12 hours, right? So if they ask at least 12 or more, then we can count equator also. So here they ask more than 12 hours, so only two can be counted, the Arctic Circle and the Tropic of Cancer. So only the 2 and 4 are correct. The answer is actually D here. I hope it is clear. So let's go to the next question. So as we know, this is actually the diagrammatic representation of what happens on June 21st. So as you know, this sun, it is actually apparently coming from this side. So when the sun looks like it is actually falling directly almost above the Tropic of Cancer. So which means that the polar regions will be experiencing high amount of sunlight, and the equator also experiencing. This particular region is actually experiencing very high amount of sunlight, but the southern region is actually experiencing very low amount of sunlight. That is why the daylight is very less. And just look at the polar circle here. This polar circle will be experiencing almost no sun at all. It will be complete darkness for the entire 24 hours. There will be complete darkness in the zone, and the complete light will be here in the polar circle in that particular date. That is called the June 21st. That is the summer solstice day. So let's go to the next question. So they asked about the question about the peatlands. So what is the question here? One of the following regions has the world's largest tropical peatlands, which holds about 3 years worth of global carbon emissions from the fossil fuels, and the possible destruction of which or those peatlands can exert detrimental effect on the global climate. Which one of the following denotes that regions? So that is the particular question here. Here the answer is actually B, Congo Basin. So we have to understand why this particular question is actually important. What is peatland and where is this particular country? For example, it is actually on the equatorial region. We have to understand. So this is the region we are actually talking about, and the Congo Basin is there. And in the Congo Basin, we can find one of the world's largest deposits or world's largest locations of peatlands. So let's identify what this particular thing called peatland is actually all about. So this is actually the other major locations are definitely Brazil, Indonesia, etc., where we can find a lot of peatlands. And this particular thing called peatlands, it is actually storage of around 29 billion tons of carbon dioxide. The world peatlands, the global peatlands are actually storing that much amount of carbon. And every year, annually, they are actually storing around 3 times the global carbon emission, right? So every year we are actually emitting global carbon dioxide, and all the greenhouse gas emissions are there. and they are actually storing almost 3 times that of carbon. Greenhouse gases are actually, or carbon actually stored within the global peatland. So that itself shows that if these peatlands are actually destroyed, which means that all the carbon, all the contents that are actually stored inside those peatlands can actually escape from the region. So just imagine if all those carbon content is escaped from those lands, it will actually exacerbate or just accelerate the rate of greenhouse gas emissions in the world. So that is why the peatlands are extremely important. That has to be very much concerned. And let's know that it actually absorbs around 1.5 billion tons of greenhouse gases and different carbon materials every year. These global peatlands are absorbing all those things. So whatever we are emitting, they are actually absorbing a part of it. These peatlands are actually absorbing that much amount of part of the carbon dioxide every year. So they are actually helping us combating the climate change and all. So there are actually 6 countries in which these 6 major countries in which these peatlands are actually spread through. For example, Cameroon is there, the Central African Republic is there, the Democratic Republic of Congo, the Equatorial Guinea, Gabon. So all these countries are actually situated on the central regions of Africa, the equatorial region of Africa. It is through this just down south of the equatorial region. So this is region through which this particular thing called peatland is actually located. And so we have to understand that even though this peatland, the area of peatland on the Earth's surface is very less compared to the other different types of geographies, even though their area is actually very less, they are actually contributing very large compared to their size. So that one important thing has to be there. They are actually acting as heavily carbon sinks and all. And we have to also keep an idea about the difference between peatlands and wetlands. So peatlands are also a type of wetlands, we can say. However, it is actually continuously waterlogged and all. So a lot of different vegetation and other plants are actually there. But if it is waterlogged, right? So which means that complete decomposition of plants are actually not happening in that particular region because of the waterlogging. So that is why it is actually called as a peatland. It is actually converted into peat. So which means that it is actually becoming a peatland because of the continuous waterlogging situation. So it is definitely a type of wetland. So we can call it a specialized wetland. That is called the peatland. It is a very heavy carbon sink also. And the answer here is actually Congo Basin. So go to the next topic, that is we are coming to the science and technology topics. So the question was actually asked on distributed energy resources. So this is actually nothing but, we can call it as like localized energy generators or storages, not the grid based, the large level storages, the local level storages or generators. That is actually called the distributed energy resources. And in this particular statement, question, 4 different things were actually given. Consider the following: battery storage, biomass generators, fuel cells, the rooftop solar photovoltaic units. Which of the following of the above are considered as distributed energy resources? We can say that all the 4 of them can be counted as the distributed energy resources. So we have to understand what this DER is, that is distributed energy resources. They are actually small energy generator units, we can say, that are actually on the consumer side. For example, I as a person can actually establish a rooftop solar photovoltaic unit. Like for example, in my home, in my rooftop, I can actually establish this thing. So I can actually create the energy which my home requires by my own without depending on the power supply generators and all. So this is actually called the this particular thing called distributed energy resource. Another example, for I can actually create a small biomass energy plant, actually the miniature plant, which is actually can be installed in my home. So whatever the waste materials created in the kitchen and all the waste materials or the vegetable, fruits and other food materials, I can actually deposit in that particular pit, and it can actually convert biomass into energy. So these things can be localized. We don't have to depend on large grids and all. So this is actually called the distributed energy resources, and all these things are actually examples of this particular thing called distributed energy resources. The answer is here is D, all 4. All right, so there is no need of any centralized generation. Going to the next question. So the question is actually about radioisotope thermoelectric generators. Radioisotope thermoelectric generators. So before going to the thing, this is actually a screenshot taken from the Hindu Business Line from the July 16, 2023. So last year. So this particular thing called radioisotope thermoelectric generators was in the news from the 2017-19. So there were multiple news materials available. But last year, this particular major news broke out that ISRO and BARC, that is Bhabha Atomic Research Center. So ISRO and BARC join hands to develop the nuclear engine for rockets. And this particular nuclear engines, they are saying, according to the sources, ISRO BARC are developing what are called the radio thermoelectric generators. So here this particular word is actually coming, radio thermoelectric generators. So these are all these, as the news itself suggests that they're actually talking about nuclear energy, one thing, nuclear engines, but not through nuclear reactors. Through what? Then through radio thermoelectric generators. So we have to understand that this particular thing is actually different from those nuclear reactors and all. This is actually not nuclear reaction. However, it is actually exploiting the radioactive decay of the radioactive elements. For example, they are actually taking plutonium 238. Here it is written. So plutonium 238, it is actually radioactive. So it will be undergoing radioactive decay, and from that radioactive decay, the nuclear energy is actually being derived. So it is not undertaking any major nuclear reactions. It is only exploring those energy from the nuclear radioactive decay only. So that is the concept of the radioisotope thermoelectric generators. So coming to the three statements here, RTGs can use plutonium-238, which is a byproduct of weapons development. So that statement is actually correct here. The third statement is actually correct. We just mentioned about that. RTGs are used for powering the onboard system of spacecraft. See, just look at that. Onboard system of spacecraft. So this particular, we just showed the news material, right? ISRO and BAR collaborating. So it is, this particular question was actually based on that particular news. So if somebody, someone has actually read that particular news event in that newspaper, which means that automatically he or she will understand that the second statement is actually correct, the spacecraft, because automatically we think about ISRO BAR collaboration. The first statement is, so the second statement also is right. So RTGs are miniature fission reactors. So we just mentioned that it is actually not undergoing any nuclear reaction. However, it is only taking energy from the radioactive decay of the mineral. We can call the mineral plutonium-238. So it is only taking energy from the radioactive decay. No nuclear reactions is actually happening. So there is no need of any mention of any fission reactors. So the first statement is actually wrong. Only second and third statement is right. So the answer here is actually box B. Right. So let's go to the next statement. So we should also keep in mind about the continuous updation of the project of ISRO, because all those deep space projects and all these things require continuous supply of energy, and this type of radioisotope thermoelectric generators are actually are very suitable for those distant battery operations and all. They can continuously give supply of energy for very long period of time. So please keep an eye on such things in the upcoming future also. So let's go to the next particular question. So two statements are given in the science and technology segment. Giant stars live much longer than dwarf stars. And the second statement, compared to the dwarf stars, giant stars have a greater rate of nuclear reaction. So giant stars have greater rate of nuclear reaction. That is the second statement is actually saying. So let's look at the first statement. Giant stars live much longer than dwarf stars. So what is a giant star? What is a dwarf star? So there are actually different types of stars which can be created, which are actually there. So we have to understand how the stars are actually originated, how the stellar origin. For example, there is actually nebula. There is actually a continuous, a group of dust and other particles, interstellar dust, everything is there. That is the nebula. From there, stars are actually forming. But when the stars are actually forming, two types of stars can form. So just look at that. If there is an ordinary type of star can form, and then ordinary type of star can form, and also a very large star can also be forming. And this ordinary star will go for a red giant star, and the very massive star will go for a red super giant star. And then the smaller red giant star will go for a planetary nebula. That is a small explosion will be there. It will not be a very violent ending for that. Eventually, it will end like a white dwarf star. So that is a dwarf star. And the supergiant star, what about that? So this has a very large mass and all, very large content of hydrogen, helium, everything is there. So it will eventually go for a violent explosion that is called a supernova. And if that mass star has a very large mass, it will eventually end up a black hole. That mother star has very large mass, then will eventually end up as a black hole. And if that red supergiant star has comparatively lesser amount of mass, then it will eventually end up as a neutron star. So these are the end products of a star: the white dwarf, neutron star, and a black hole. The more the mass, the more possibility of becoming a black hole. The lesser the mass of the star, eventually it will become a white dwarf.
our own sun in our own solar system is expected to be a white dwarf star because it is a very small star compared to us, compared to the different stars. So let's in that particular, if you get the concept of the particular thing called giant stars, let's go back to the question. So you have to understand that the giant stars actually has a very shorter lifespan than a dwarf star. Why? Because the giant star has a very massive core. There's a very large mass. There is a lot of different hydrogen and helium. All those things are actually being created in the area, which means that the energy reaction, the burning of nuclear fuel is actually very rapid. It will be very violent. It will be very, rapid nuclear reactions are actually happening. The energy is actually continuously emitted violently. So everything is actually happening violently and very quickly. So which means that the very high amount of nuclear rate of nuclear reaction, which means that ultimately the hydrogen, the amount of hydrogen will be depleted very quickly. So that is actually what happening in the giant star, which means that the first statement, the giant stars live much longer than dwarf stars, that is actually wrong. Why? Because when the mass of the star increases, the rate of nuclear reaction inside the star also increases, which means that the hydrogen will continuously be quickly depleted into helium, and helium will deplete into further elements until up to iron. When the iron state is actually raised in the chemical periodic table, then the star will not be able to sustain that reaction. Eventually, it will implode together. So that is actually happening in a star. So this particular statement is wrong. Giant stars will have lesser amount of lifespan than a dwarf star. Second thing, compared to the dwarf stars, giant stars have a greater rate of nuclear reaction. We just mentioned about that. The more mass the star has, the more amount of energy it can create. So which means that the nuclear reaction, the speed and intensity will also be higher. So the second statement is actually right. So the answer here is actually dog. That is the statement 1 is incorrect. The statement 2 is correct. So the answer is actually D. So let's go to the next few questions left. The next statement here is actually, yes. Which of the following is synthesized in human body that dilates the blood vessels and increase the blood flow? And 4 options were given: nitric oxide, nitrous oxide, nitrogen peroxide, pentoxide. So this is actually a very confusing question. Definitely those people who know, who have actually read about this particular thing only may be able to get this particular type of question. So the answer here is actually, we just go through that first. It is actually A, that is nitric oxide. That is the answer here. So let's understand what this particular thing is actually about. So what happens is that, as you can see in the first image, this is the blood vessel, right? So when this particular thing, blood vessel, it is actually when it is supplied with the nitric oxide, what happens is that it plays a very crucial role in vasodilation. So what do you mean by vasodilation? It means that there are actually muscles in the blood vessels, right? So what this particular nitric oxide does, that it actually makes the muscles inside the interior muscles of the blood vessels in a very relaxed manner, which means that it will dilate. So earlier it was very constricted, it was very narrow. So once the nitric oxide is actually given, the vessels become very relaxed, the muscles become very relaxed. The vasodilation is actually happening there, which means that ultimately it dilates the entire blood vessel, so that it will be very easy for the blood to flow through those particular regions. So that is the particular purpose of this nitric oxide. It is a very crucial role in vasodilation. That is the increasing blood flow. That is the purpose which is actually being done by the thing. And it is actually relaxing of the, vascular muscles in the arteries and all. So that is the purpose of the particular thing called nitric oxide. And ultimately it will have better cardiovascular health. All those people who are suffering from cardio health and all these things, they are given these type of drugs and all. So better cardiovascular health, and to lower blood pressure, that also things can be done by the nitric oxide. So the answer here was actually A, nitric oxide. So the next question is actually, consider the following activities. So we are actually talking about radars. So what of the above things can be in what of the things above radars can be used? So what are the 4 things? We can do the second thing. For example, monitoring of precipitation and tracking of precipitation, then the tracking of migration of animals, and the identification of narcotics on passengers at airports or in aircraft. So let's look at the thing called radars. So what are radars? They're actually using waves, right? Electromagnetic radiations are actually being used. For example, different types of radio waves and other microwaves, different types of waves can be used in different types of radars. So ultimately, this is actually using electromagnetic radiation. And using this electromagnetic radiation, you can actually detect some metal particles, something like that. But it is actually not possible for those radars to detect narcotics or on the different passengers also. So that is one important thing we can actually strike off here. So one is actually not there. Coming ahead, how does this radar work actually? They actually emitting different, transmitting different pulses. And once the pulse actually reach one destination, and when it is actually reflecting back, that is when it is actually analyzing the reflection and identifying what particular object I just encountered. So that is how the radars are actually working. So it can measure distance, it can measure speed, it can measure the different direction of flow. So those kind of things can be measured by the particular thing called radio radars. And it is actually used for different civilian purposes, different military purposes, etc. For weather forecasting also. Weather forecasting also, which means that when we can easily identify the tracking of the precipitation, if there is intense rainfall happening because of any cloud burst, etc., we can track that cloud. So the tracking of precipitation can be done. Then monitoring of that precipitation, if the rainfall is increasing or decreasing, these kind of things can be monitored. So 2 as well as 3 can be taken. And then tracking the migration of animals also. For example, surveillance and tracking. If an animal, for example, recently there was a event of a violent animal that was actually captured by the forest department of Kerala. Then it was actually transported to one forest. Then it actually let loose. It went to some villages of Tamil Nadu. Then it was again captured. So how this tracking of elephant was actually done? Because of the radio collar in the neck of that elephant. So this tracking of the migration of animals can also be done with the help of radars. So the third statement is also correct. So what is the wrong statement here? Only the first one. So how many of the above activities can radars be used? All the 3 things can be done. So that is the third thing. The answer is actually C. The next question, consider the following aircraft, the fighter jets actually. Rafale is there, the Dassault Rafale, which India actually purchased from France. The MiG-29, which the Russia is actually manufacturing. Then the Tejas Mk1, which is the indigenous fighter aircraft of India. So consider the 3 aircrafts, and they are asking us which of the above are actually considered the 5th generation fighter aircraft. We can see that none of the things are actually the 5th generation fighter aircraft. So that is the answer. None of them are actually the 5th generation fighter aircraft. So there are actually a lot of 5th generation aircraft, such as the F-35 Lightning, which is actually used by the United States. There is actually the Sukhoi Su-57. The 57 Su Sukhoi is actually a 5th generation aircraft. Then there is a F-22 Raptor. All those things are actually 5th generation, but none of the things listed here are actually 5th generation aircraft. So all those things, the Rafale, the MiG-29, MiG-29 is actually, we can call it a 4G. The Tejas is also 4G, but we can use the word 4.5G. The Rafale, the Dassault Rafale, that is actually, we can call it as a 4.5th generation. So ultimately, all those things are part of 4th generation. It has not yet reached the 5th generation. So the question arises, what is a 5th generation aircraft? So this is actually, the 5th generation aircraft has more stealth capacity. Stealth means hiding capacity. It is very difficult to detect this particular aircraft in our current radars and all. And the major technologies of the 5th generation aircrafts are created in the 21st century only. And last but not the least, it has more avionics, more technologies, more maneuvering abilities, and all. It can detect dodge the different incoming attacks and missiles and etc. So much modern technologies are actually applied in the particular 5th generation aircraft, and none of these are actually part of the 5th generation aircraft. So the answer is actually D, none of the above. And you must have seen different. This is actually a screenshot taken from the newspaper. So you know the difference between. So none of the things which we just mentioned, the Rafale, none of these are actually becoming the 5th generation. So we already mentioned about the different examples of 5th generation also. For example, F-35, Sukhoi T-50, all those things. But our Tejas is also not part of the 5th generation. It is only part of the 4.5, or generally, broadly speaking, the 4th generation aircraft only. So going to the next question, which of the following are hydrogels used? And 3 different things are actually being given. 3 options are given. So let's understand what a hydrogel is actually about. So you can see from the picture that one layer of the layer is actually, one almost translucent layer is actually applied to the skin actually. So what is this particular thing hydrogel actually does? So this particular layer is actually created out of hydrogel. And different news materials were actually in the news recently regarding the hydrogel. That is, the IAC researchers designed novel hydrogel to remove microplastics from water. Then the next thing is actually immunoprotective vesicle crosslink hydrogel for allogenic transplantation. So a lot of different things are actually, hydrogel was in the news recently. So we have to identify what are the important properties of hydrogel, what is this particular thing hydrogel, etc. So this thing hydrogel is actually a very water absorbent cross-linked polymer. So what ultimately happens is that it can be used for, it can hold large amount of water. It can easily absorb water, it can hold the water, and it can release the water or release the moisture or the content in a very controlled manner. So which means that it can be used for controlled drug delivery also. So the drugs can be injected into that particular hydrogel. It can absorb it, it can hold it for very long time, and only when it is actually required, it can release that particular drug in a very controlled manner. So that is one purpose of the thing called hydrogels. And the second is the mobile air conditioning systems. So in the air conditioning systems, so one factor, important factor regarding the air conditioning systems is humidity. So just imagine if the hydrogel can actually store water and it can actually release water only when that is required. That is, it can control the humidity, which means that it can definitely alter the air conditioning systems. So the humidity factor comes into play. So that is where the second thing actually also is correct. Preparation of industrial lubricants. So this one thing also has to be, is actually also correct. So which means that both the 1, 2 and 3, all the things are actually correct in regarding the hydrogels. And it is actually used in the different industrial lubricants to reduce friction, and it has high thermal stability also. So all those things are actually helping hydrogels becoming a favorite thing for the to be used as industrial lubricants also. So the statements, all the three statements are correct. The answer is actually D. Okay, coming to the last few questions from the science and technology portion. Which of the following is the exhaust pipe emission? So which of the following is the emission from the fuel cell electric vehicles? So it is not a combustion vehicle. What is a combustion vehicle? Which actually uses all the petrol, diesel, all these things. With internal combustion engine is there. So that is the combustion engine. So this is actually a fuel cell electric vehicle. So which of the following is the exhaust of those fuel cell vehicles powered by hydrogen? So what happens in a fuel cell vehicle is that you must be knowing about different renewable energy sectors. Last year, there were 2 questions on green hydrogen and all. So hydrogen was definitely supposed to be a question in this particular year also. And normally in a fuel cell electric vehicle, the normal exhaust or the byproduct is water vapor or water. So if we look at the exhaust, only the water droplets will be coming out. So the answer here is actually water vapor, and you can safely reduce one particular thing. For example, oxygen is flammable, right? So the something which is flammable will not be coming out of the exhaust, so you can strike down that. And the hydrogen peroxide is actually commonly used in different chemicals and all. That is not definitely a part of the chemical reaction. Hydronium, even if you don't know what the hydronium is actually, you know that not this particular thing. This fuel cell exhaust will not be having that type of words. This is actually a very easy question. The water or the water vapor, that is the exhaust, supposed to be a very easy question. So the answer here is actually D, water vapor. The next question. Recently, the term pumped storage hydropower is actually and appropriately discussed in the context of which of the following? So let's look at this particular image. This is a question actually. The states, this news actually appeared in the recent newspaper, Hindu newspaper, on January 25th of 2024. The stage is set for laying foundation for 2 pumped storage hydropower. That was the question, right? Storage hydropower projects in Andhra Pradesh. So that was the question. And let's look at the image here. So this is basically, I'll tell you the concept here. So basically, we have 2 reservoirs. One is actually on the lower altitude. One is actually on the higher altitude. So I require some amount of power here, some amount of energy here. What I will do initially, I will take the water from the lower reservoir to upwards to the higher reservoir. Then what will I do? I'll store it there. So the water was initially here. I took some of the water to the upper level and I store it here. So what happens is that the energy supplied by me is actually stored there. right? So the energy is there. So when I require water, till then the energy can be stored there. So once I require water, once I require energy for some purposes, what I do is that I let the water from the upper level flow down to the lower level. So when the energy is actually flowing down, it flows through a turbine, and the energy is actually retrieved again, and that energy can be used again. So I can store energy for long durations. That is the purpose of this particular system. And so let's look at the question again. What is this particular pumped storage hydropower is actually? It is actually for long duration energy storage. So I can store the energy, that too for long durations. So only when I require energy, I can take that energy back. So that is the purpose here. Answer here is actually C. So the next question is actually about membrane bioreactors. We already mentioned about the aquaculture, the membrane used in the aquaculture, etc. in our class and all. So what is this thing called membrane bioreactors, which are actually often discussed in the context of, this is actually discussed on the context of D, that is wastewater treatment technologies. So what does this particular thing actually do? So this is actually a very compact or efficient technique. It is actually used for the treatment of the wastewater or the municipal or the industrial wastewater treatments. Ultimately, two things are actually here. One is actually bioreactors, right? So one is actually bioreactor, which means that a lot of microorganisms are actually in the particular system. These microorganisms can do different chemical reactions, and it can ultimately lead to very clearer or very less pollutant water. And there is membranes also. And when these membranes, the water is actually passing through the membranes, what ultimately matters is that the water gets filtered out of further pollutants. So the end result is a more clear, less polluted water. And multiple stages are actually said, and multiple times the water actually goes in and out of these particular membrane bioreactors, and the end result is actually the perfect purified water. So this is actually not the edible drinkable water is not, even though it is not created, the water will be less polluted when it is actually passing through the membrane bioreactors. So the answer here is actually wastewater treatment technologies in the industrial and the different municipal wastewaters. The next question, it is supposed to be a very easy question. Which of the following words or a phrase is most appropriately used to denote an interoperable network of 3D virtual worlds? So it is an actually interoperable network of 3D virtual worlds that can be accessed simultaneously by millions of users who can exert property rights over virtual items. So this is actually, they are itself saying that it is a 3D virtual world, and we can buy property, we can buy house, or we can buy park or buildings, etc. in that virtual world. In that those virtual items can be bought, and it is an interoperable network, and it is actually simultaneously used by millions. So multiple people can access the very same world, virtual world together. We can buy property, the digital things. We can buy a digital school or a building that like a game, etc. So what is this particular thing? This is actually, the answer is metaverse. See, metaverse. So let's look at what this particular thing is. This is definitely not virtual reality. The two other different words are augmented reality and virtual reality. So this is not virtual or augmented reality. This is something else. We are creating an entirely separate digital 3D virtual world, and that world is actually called as the metaverse. So we can actually create our own avatars. Our own characters can be created in that virtual world. And when we when we go to that virtual world with the help of such Googles and all, we can see that we can walk through that entire different world. We can buy things. We can have our own currencies. We can do trade. We can do economics. If we see one particular house, like the particular this thing, I can buy this particular house. It will be my own property. This digital property will be mine. And if some other person comes and see this particular house, this digital house, like a game, right? So that if that person is interested, we can negotiate with that person. I can sell this particular property to that person. So just like that, property rights can also be owned in this particular virtual world, and this is actually called the metaverse. So this all the social and economical connections can be made, currency, trade, different property exchanges, and so this is actually a replica of the real world. We can say this is not the real world. This is a virtual world only. So this is a replica of the real world, and a civilizational approach is actually taken. Like a lot of different civilizations, like people interactions can be done in this particular technology. And last but not the least, please keep in your mind that what technology is actually used as a bedrock. It is actually based on the blockchain technology. So the blockchain is actually continuously being asked in the UPSC. It is a very heavy, important topic. So please note whatever things happening in the blockchain technology will automatically be important in the UPSC also. Going ahead with the last questions. The next thing is actually consider the following countries. So 5 countries names are given. Which of the above countries are frequently mentioned in the media for their low birth rate? So this is actually in the human geography question, or aging population or declining population. So low birth rate or aging population or declining population, which of the countries are actually being mentioned in the news recently? So we can spot 3 different countries. One is actually Italy, the second is Japan, the third is actually South Korea. So multiple, for example, Japan is the most vulnerable country in this particular thing. So they are always in the news regarding the aging population, and there were news, for example, the India and Africa are actually collaborating to supply human resources to Japan also, because they need a lot of human resources, skilled resources are required, nursing requirements are there. Why? Because they are having an ultimately aging population is there. 65, the age of 65 plus people are actually increasing manifold in Japan. So they need a lot of different human care activities, nursing and other activities are required there. So India as well as different African countries are collaborating to supply those human resource requirements. So Japan is always in the news. South Korea, they have one of the lowest, and they have the lowest fertility rates in the world also. And it is expected that the United Nations even warned South Korea that by the end of 2100, that is by the year of 2100, it is expected that the population of South Korea will be half of what it is actually right now. So they are actually declining population trend is visible in South Korea. So they have a very low fertility rate. And the third one is actually Italy also. And 1/4 of their population, the total population of Italy is actually more than 65 years old. That means they're actually having a very aging population also. So they have low birth rate also. So all those 3 countries are actually or hit list. All those 3 countries satisfy your condition. So what are the 2 countries which is not satisfying your condition? Nigeria and South Africa. So Nigeria, we have to understand that the birth rate is very high. The fertility rate is also very high. For example, on an average, for every woman in Nigeria is experiencing 5.24 birth per woman. So that is a very high fertility rate, and there is almost 36.4 people are being born out of every 1,000 people in Nigeria every year. The situation in South Africa is not that much heavy, but still, the South Africa also has around 20 people per 20 births per 1,000 people every year. So the South Africa and Nigeria can be excluded here. Italy, Japan, and South Korea are our favorites, which means that the answer is 1, 2, and 4. The answer is A here. The next question here is actually talking about the longest border between any 2 countries in the world is between. So when we look at the particular thing, it is actually the Canada and the United States of America. That is the answer here. A is the correct answer here. We can strike out one thing, that is China and India. It is not the correct answer. Why? Because India has its largest border not with China but with Bangladesh. So this is actually definitely not the right answer here. We can strike out that particular thing. So when we go to the different borders, actually, just looking at the map. Looking at the map here, the United States of America and Canada border is not just here, but also here also. So this is actually Alaska. This is actually Canada. This is actually mainland United States of America. So the border is actually a combination of this plus this. So ultimately, the border is around 8,890 kilometers. So this is the longest border, national border in the world. The next thing is actually coming to the Chile and Argentina. So this is the border of Chile and Argentina. It is a very earthquake prone area also. And this particular thing is actually having almost 5,300 kilometers, around 5,000 kilometers of border is actually between Chile and Argentina. And the next thing is actually the Indian border. Even though the map looks small, the Bangladesh border, the India-Bangladesh border is more than the India-China border. And the last thing is actually about Kazakhstan, the Russia-Kazakhstan border. So this is actually Kazakhstan. So when we look at the Russia-Kazakhstan border, we can say that it is almost 6,846 kilometers. So that is even still less than that of Canada and USA. So that is the correct answer. Canada, the border between Canada and USA is the longest national border in the world. Coming to the last question of this particular session, to consider the following statements. 2 statements are given. The Red Sea receives very little precipitation in any form. That is actually very correct answer. First thing, no water enters the Red Sea from the rivers. So that also is a correct statement. The answer is actually both 1 and 2. So you have to understand the location of the Red Sea actually. So just look at the Red Sea. It is actually surrounded by two different land masses. On the particular eastern side, you can see the Saudi Arabia, Yemen, and Jordan, and all these countries. On the western side, you can see Egypt, Sudan, Ethiopia, Somalia, etc. So it is actually extending from somewhere here. That is actually the Suez Canal, and it is actually coming to here, Bab el Mandeb Strait. So between Suez Canal and Bab el Mandeb, and then coming to the Gulf of Aden. So this is actually the Red Sea area, and it is actually a very because of this particular land masses around it, which means that the water will automatically be very warm, which means a lot of evaporation rate is there. Ultimately, which means that the water is hotter and also the water is more saltier. Why? Because the rate of evaporation is more, right? So as the water actually moves out, whatever things remain, the salt is actually density of salt is increasing. So the water is more saltier, it is more warmer also, and there is no river discharge to this particular region also. Let's look at the Nile River. Nile is actually going and it is actually ending like this. So nothing is actually going to the Red Sea area. Everything is actually discharging into either Indian Ocean or to the Mediterranean Sea, nothing to the Red Sea. So that also is actually correct. So no river discharge plus less rain plus higher evaporation loss, which means that the Red Sea is actually more saltier. So here we are actually ending this particular session. I hope most of the questions were actually easy questions were there. And we can see that the geography questions, we discussed geography and science and technology. Almost all of the geography questions are basically asked on the foundation of the topic, subject only. From the NCERT textbook, we can easily get the basics. But the current affairs, the science and technology questions, on the other hand, required a very good hand on the current affairs and other topics. Very good hold was actually required. So that is the trend which was actually visible in the geography as well as science and technology questions. And also make note that a lot of different map-based questions were there. Again, Africa-based or African-based actually question is actually again up. So Sahel region, peatland question, and this particular Red Sea question. So the particular continent of Africa is always in the limelight when it is actually in the UPSC perspective. So make sure that you study the maps and whenever it's actually required, no need to open your atlas and study the maps per se. But whenever something happen in one particular region of the world, when you study that event, also take out the atlas, then you just understand which region is that. That is how you should study the atlas and study the places also. So thanks for listening. So we are actually winding up this particular session. Thank you.